So welcome to the deep dive. We're going to try a little thought experiment to start us off today. I want you to imagine it's the early 1990s.
A very different computing landscape back then.
Oh, completely. You've got your computer and the hard drive is, it's a mere 20 to 80 megabytes, which is nothing today. And expanding it costs a staggering $10 per megabyte.
Yeah, which was a huge barrier for, well, pretty much everyone.
Exactly. So what do? Do you empty your wallet for a new drive? Or do you turn to this almost magical software wizardry from the 90s known as disk compression? Because that's our mission today. We are exploring this technology that seemingly just doubled a computer's physical storage out of thin air.
It really did feel like magic to users back then. I mean, you have to remember, software was rapidly getting bigger, and physical storage was incredibly expensive.
Right. Okay, let's unpack this. Because the idea of just downloading space sounds impossible. I always picture it like a magical suitcase. You have the suitcase, and the exact second you pack your clothes into it, it automatically shrinks them down to half their size.
That's a great way to visualize it.
Right. And then the second you pull a shirt out, it instantly expands back to its normal size. And the wild part is you never even have to press a compress button. It just happens.
And that automatic nature is what grounds your analogy in the actual technical reality of our sources. Yeah. Because we really need to establish the difference between standard file compression and true disk compression.
Which are two very different beasts.
Right, completely. With file compression, like zipping a file, it's interactive. You manually tell the system to pack it up, and you manually tell to extract. But disk compression was totally non-interactive. It operated entirely in the background. It was on the fly, completely transparent, and happened in real time.
So the user and I guess the software they were running had no idea this was even happening.
Exactly. Your word processor, your games, they didn't know they were asking for compressed data. They just asked the system for a file, and the disk compression utility would grab it, decompress it instantly, and hand it over.
Okay, so how did it actually pull off this illusion? Because you're basically creating physical space using only software.
Well, it did this by essentially hijacking the file access layer of the operating system. When you installed one of these utilities, instead of saving thousands of individual files scattered all over the physical magnetic platters of your hard drive.
Which is how it normally works.
Right. Instead of that, the software created a single massive hidden file on the host drive. They usually called it a virtual drive. So every single thing you saved was secretly being compressed and stuffed directly into this one giant monolithic file by a special device driver.
Wait, if everything is living inside one giant hidden file, doesn't that mean the computer is basically lying to the user about what a drive even is?
What's fascinating here is that, yes, the computer was entirely abstracting reality. It was a complete deception. Wow. Yeah, the setup process was wild. The utility would first create this empty virtual drive, which, again, is just one massive hidden file. And then it would systematically transfer almost all of your files from the physical host drive into that compressed file.
Wait, you said almost all. Did it leave some stuff behind?
It had to. You couldn't compress vital system files, specifically the swap file.
Ah, right.
Because if you compress the swap file, which manages virtual memory, the computer would basically lock up trying to decompress its own working memory to function. So it leaves that alone, moves everything else into the hidden file, and then it simply inflates the reported size of that virtual drive.
So it just tells the computer, hey, look at all this free space I suddenly have.
Exactly. It reports the expanded theoretical size, leaving the operating system totally oblivious to the real physical limits.
But, if the entire C drive is secretly just a hidden file on the physical drive, how does the computer even wake up? Like when you turn a PC on, it needs to read the C drive to boot. But if the drive is fake and the driver needed to read it is locked inside the fake drive, it's a total chicken and egg problem.
It is a massive paradox. And solving it required some incredible sleight of hand during the boot sequence. Let's look at the historical DOS boot process from the sources to see how they tricked the system.
Okay, lay it on me.
So you press the power button. The system BIOS wakes up and it looks at the very first sector of the hard drive, the master boot record, or MBR.
Right, the absolute baseline hardware level.
The MBR then loads the volume boot record, which in turn loads the DOS BIOS. These are hidden system files, usually IOSYS or IBMBIO.com. At this stage, DOS is loading into basic memory, but, and this is the crucial part, it hasn't loaded the config.sys file yet.
Meaning no third-party drivers are loaded. The computer still thinks the physical hardware is the real C drive.
Exactly. And if it kept booting normally, it would just crash because
Mm.
all the user files and the rest of the OS are trapped inside that unreadable compressed monolith.
So how did they bypass the crash?
In MS-DOS 6.0, Microsoft introduced an undocumented challenge response interface known as the Preload API.
Here's where it gets really interesting because I picture this like intercepting the computer's morning coffee. The machine is just waking up, going through its groggy morning routine, and this preload API just steps in front of it.
That's a perfect way to put it. Right after the DOS BIOS loads, but literally milliseconds before it reads the user's config files, the system pauses. It scans the root directory for specific preload drivers, files like dblspace.bin or stacker.bin.
So compression drivers.
Right, and if it finds one, it initiates this secret handshake. If the driver gives the correct mathematical response, the system loads it into memory immediately, completely bypassing normal configuration.
And what does the driver do once it's in?
It immediately executes a radical maneuver. It literally swaps the drive letters in the system's RAM.
It swaps them. So it puts on a mask and says, hey, look at me. I am the C drive now.
Yes. The physical drive is shoved aside, usually reassigned to a random letter like H, and the fake compressed file is mounted and declared the C drive. And from that millisecond on, the computer finishes its morning coffee, completely oblivious that its entire reality was just remapped.
That is just wild. But, I mean, tricking the computer's brain and stuffing literally all your data into a single hidden file sounds incredibly risky. Like, what were the unintended consequences of doing this? Because this has to have a catch.
Oh, there were several massive catches. But before we even get to the data disasters, we have to talk about the performance paradox.
Okay.
You'd naturally assume that forcing a computer to do complex math to compress and decompress every single file in real time would make the whole system sluggish.
Right, yeah. I mean, you're giving the CPU a massive extra chore for every single task.
Well, the sources show it actually depended on where your bottleneck was.
Yeah.
If your system was CPU-bound, meaning the processor was already struggling to keep up with basic tasks, then yes, disk compression slowed everything to a crawl. The math was just too heavy.
So it was just choking the processor?
Right. But if your system was I/O-bound, meaning you had a fast processor, but a really slow physical hard drive.
Which was pretty common back then, waiting for the physical platters to spin.
Exactly. For those I/O-bound machines, disk compression actually increased overall performance.
Wait, really? It made the computer faster? How?
Because there was physically less data to read and write from the slow mechanical drive, the fast processor could read a tiny compressed file from the disk and decompress it in RAM significantly faster than the slow hard drive needle could read a massive uncompressed file.
Oh, wow. So the math was actually faster than the physics of the spinning disk. That's brilliant. But obviously, performance aside, the risks to your actual data had to be astronomical.
They were. The nightmare scenarios usually began with a very simple user action, trying to uninstall the software.
Because it's a trap.
A total trap. If your expanded, uncompressed data exceeded the physical size of the actual hard drive, uninstallation was mathematically impossible unless you deleted enough files to fit back into reality.
You literally couldn't escape the virtual space you built.
Exactly. And it gets worse. A massive danger lurked during the initial setup phase. The compression utility relied completely on the integrity of your drive's FAT file system to move your data safely.
The file allocation table, basically the index card catalog for where data lives on the disk.
Right. So if your drive had pre-existing errors, particularly something called cross-link files, where two files accidentally claim the same physical cluster on the disk, the results were catastrophic.
Uh-oh, because the setup program is sweeping through, grabbing clusters, compressing them, and then what, deleting the originals to save space?
Yes. It would compress the cluster for the first file, delete the original, and move on. So when it eventually got to the second file that claimed that exact same physical space, the data was already gone.
Oh, man. Massive data loss during the initial trap.
Massive. It would corrupt files and could even destroy the virtual translation table itself, ruining the entire drive before the installation even finished.
Which leads to my biggest question. What happened if a user was just, poking around their hard drive, making hidden files visible, and they saw the suspiciously massive file eating up basically 100% of their space? What if they just deleted it?
I mean, that is the most human error of all.
Yeah.
Because the file was hidden, but curious users often found it. And because they didn't grasp the abstraction, they didn't realize that one file was their entire operating system and all their personal data, they'd hit delete to free up space.
Oh.
Total annihilation. Deleting that one file meant losing every single thing stored on the compressed drive instantly.
Just boom, your whole digital life is gone. But despite that risk, people still used it. Because, well, it was either this or shell out hundreds of dollars for a new drive.
Exactly. The high cost of hard drives made this software an absolute necessity, which sparked a massive multi-million-dollar industry arms race.
So let's talk about that arms race. Because the tech really had to evolve to keep up, right?
It did. In the early days, CPUs were just too weak to handle the math, so the first solutions were actually hardware-assisted.
Oh, like physical add-on boards?
Yeah, companies like Stack Electronics with their Stacker product, or InfoChip Systems with Expanse,
Yeah.
they sold physical coprocessor boards that plugged into the motherboard. These had custom chips designed specifically to do the compression math, taking the load off the main CPU.
But eventually processors got faster, like the 486 and the Pentium.
Right, and once the CPUs gained enough power, the hardware boards became obsolete. Software-only solutions completely took over the market. We saw programs like Squish, Superstore, and Double Disk dominating.
And computer resellers loved this, right? I mean, they were bundling this software onto PCs just to claim their computers had more storage without actually buying bigger hard drives.
Oh, it was a massive marketing gimmick. And the operating system developers caught on quickly. Digital Research bundled Superstore into Docker DOS 6.0, and Microsoft bundled Doublespace, which licensed Double Disk Tech, into MS-DOS 6.0.
Okay, I wanted to ask you about this because there's a very curious detail in the sources. I see that MS-DOS 6.22 bundled a program called DriveSpace, but the version right before it, MS-DOS 6.21, shipped it with no compression software at all. And the sources mention legal reasons. What does that tell us about the climate back then?
Impartially speaking, without getting into the weeds of the specific patent lawsuits, that gap in MS-DOS versions really highlights how intensely competitive and legally fraught this industry had become.
I mean, it was virtual real estate.
Yeah, exactly. Companies were aggressively patenting their algorithms and their integration techniques. It was a highly lucrative market. And the fact that a flagship OS like MS-DOS had to temporarily strip out its biggest feature shows you just how fierce the legal battles over this intellectual property were.
Right, everybody wanted to own the rights to thin air.
And the technology was getting incredibly advanced before the whole industry eventually collapsed. For instance, the sources detail how Novell DOS 7 bundled a DPMS-enabled version of Stacker.
What does that mean for the user?
It meant that if you had Stacker on your local machine and Stacker on a remote network server, they could exchange data packets across the network while keeping them compressed.
Wait, so they didn't have to uncompress the file, send it, and recompress it? They just sent the shrunken version.
Exactly, which effectively doubled the network bandwidth. It was a brilliant use of the technology to speed up entire local area networks.
That's actually amazing. So what does this all mean for the listener today? I mean, where did all this fiercely contested tech actually go? Because we don't buy box software to double our drives anymore.
It essentially faded into disuse by the late 1990s. Hard drive manufacturing advanced so rapidly, and the cost per megabyte dropped so low that physical storage became incredibly cheap.
So it just didn't make sense to risk your data with a virtual drive anymore.
Right, but the DNA of the technology absolutely survives today. Windows still supports NTFS compression, which blends traditional file compression with those transparent on-the-fly concepts we just talked about.
So it's still running in the background.
Yeah. And the open source community kept the legacy alive, too. Linux developers created drivers like DMS-DS specifically to read those old 90s Stacker and Doublespace volumes, preserving that history.
Which is pretty cool. It just quietly became part of the background architecture of how we compute. Which actually leaves us with a really fascinating final thought to mull over today. Yeah, because for an entire generation of computer users, disk compression was their very first introduction to the concept of virtualization. It was the first time we learned that the hardware you think you're interacting with, the space, the folders, the drive, can actually just be a software illusion.
That's a really good point. It completely decoupled the physical reality from the digital experience.
Exactly. So as you go about your day today, as you look at your cloud storage or use virtual machines or log into simulated environments, ask yourself, how much of your current digital world is actually real physical hardware? And how much is just a modern version of a giant hidden file pretending to be a hard drive?
Something to think about.
Definitely. We'll leave you with that. Thanks for joining us on this deep dive.